Okay, good morning, class. So let me just present to you today the mixed circuit. Okay, so the mixed circuit. How are we going to compute for the total resistance? Okay, so of course, if we are going to compute for the total resistance in a series circuit, we will just have to simply add the different resistance given in the problem or in the circuit. Okay, like for example, this one. Okay, like for example, this one. This is a series circuit. This one is a series circuit. So according to Ohm's law, this is just the total number. The total resistance is the combination of the different resistances in the circuit. So that's why if the given for R1 is, for R1, we have here 2.2 kilo ohms. For R2, we have here 6.2 kilo ohms. For R3, it's 1.3 kilo ohms. Of course, before we add all this, the first thing that we're going to do for us to have an accurate result is to convert this into ohms. Since it's kilo is 1,000, equivalent to 1,000 ohms. So therefore, we'll just have to convert it to ohms. So that's why instead of using 2.2, we will have it here in ohms, not in kilo ohms. So it will become 2,200. For R2, 6.2 kilo ohms, convert it to ohms. So it's 6,200 ohms. And then for R3 is 1.3 kilo ohms. That's why it's 1,300 ohms. So you just have to add the different resistances. So you will see here, it's 2,200. It's 2,200 plus 6,200 plus 1,300. So equals 9,700 ohms. So that is the total resistance. Now, we're now in parallel circuit. Take note, class, that we have here one of the laws. It's stated here, the total resistance is less or approximately equal to the smallest resistive branch. So here, in getting the total resistance for the parallel, we can use either the product over sum or the inversion or the reverse method. Okay, like for example, in this circuit, we have here, now, I observed that some of the students would ask me, Mom, why it is 100, why this 100 milliampere becomes 0.1 milliampere, because this 0.1 has been converted already to ampere. So that's why it's 0.1. So 100 milli is 1,000 negative 3 raised to negative 3. So that's why 100 milliampere is equivalent now to 0.1 ampere. Okay, now going back. So take note, class, that for the parallel, for the for you to be able to check if your answer is correct, then make sure that the total resistance is less or approximately equal to the smallest resistive branch. So you will see now here, class, we have here the given R1 is 3 kilo ohms, R2 is, let's see what is R2. R2 is 6,000 ohms. And then R3 is 3.2 kilo ohms. So here we already have here the total resistance. We were now going, the resistances for the parallel here is already complete. So you will see Now here, the two method on how to get the total resistance. Product over sum, you can either use product over sum or this reverse method. For you to be able to check, you can use both method to check whether your answer is really correct. So if your answer in solution A is the same with solution B, so therefore, you are now pretty sure that your answer is correct. Okay, now product over sum. So like this one, R1 times R2 over R1 plus R2. So that's it. Okay. The total resistance. So we have here, for example, and here 3,000 times 6,000 over 3,000 plus 6,000 equals to 18,000 over 9,000. So 200 times 2,000. So that will be 2,000. So that will be 2,000. And then we're going to add the 3,200, which is the 3,200, which is the R3. So same process will be done. But here in solution B for the reverse, you can just include the R3. Like for example, this one, 1 over, that is 1 over R1 plus 1 over R2 plus 1 over R3. So you will get this result. Now compare, it's just the same. So it's just the same. Now going back to the law, it says that the total resistance is less or approximately equal to the smallest resistive branch. So what is the smallest resistive branch here? That's the lowest is 3. And the total is 1, 2, 3, 0. So correct. So it applies the law in parallel in getting the total resistance. Okay, now question, how about if the circuit is mixed? When we say mixed, in a circuit, there is a combination of series and parallel circuit. So if that is the case, first, of course, like for example, in circuit, in this part, R1 and R2, it's parallel. So you just have, what you're going to do now is to apply the formula how to get the total resistance for parallel. So for example, here you will see now R1 plus R1 and R2, that will be 2.1 ohms. And then if you already computed the total resistance for R1 and R2, which is in parallel, and of course we'll be using the formula for the parallel, then of course, next is the series. So the next that you're going to do now is to apply the series formula, in which you just have to add. So you just have to add the total number of the resistance for R1 and R2, since it's already series here it's connected in series connection to R3. So that's it. So that's why we have 4.1. Then you will see here in the next circuit for R4, R5, R6, it's a combination. So the first thing that you will do now before you add the total for R1, R2, R3 is to compute first the parallel. But if you're going to take a look at R4, R5, R6, there is this series. So first, you add 4 and 1 before you apply the formula for the parallel in getting the total resistance for 4, 5, and 6. So you see, you add first R5, R6. So that's why we have here the 4.1. Then the next that you're going to do, here, so that's why we have 5 ohms. So the next is use the parallel the total formula, the total resistance, the formula now is per parallel. So product over sum or the reverse for you to be able to get the R4, then the total of 5 and 6. So that's it. If you're able to get it already, that is now the time that you are going to add the total of R1, R2, R3 to the total of R4, R5, and R6. Okay? So that is the mix.